All right, so let's look at this. It says it's a non-calculator problem. It says find the volume of the solid of revolution formed by revolving the region bounded by the graphs of, okay, y equals 8 is up here. That should be x equals 0. Y equals 0. And x equals 2. Well, right now we can see that that area would be a rectangle, and we're revolving it around the y-axis. Okay, so because it's going around the y-axis, we're going to tell ourselves it's a shell. The volume is 2 pi times our x limits of integration. That's 0 and 2. Okay, are we revolving around the y-axis, or is it some other vertical line? It's the y-axis, so it's going to be x times top function minus bottom function. So that'd be 8 minus 0, so that would be 8. And this is a non-calculator, so technically we're saying take the integral from 0 to 2. We're going to times by 2 pi of 8x. Well, really, I can bring the 8 out in front, so I'm going to write that as 16 pi. I'm going to take the integral of x. Well, that would become x squared over 2. We're going to times that by 16 pi. Now I'm going to multiply by 16 pi here at the end. I'm going to, though, however, simplify that. My limits of integration are 2 and 0, so I'm going to plug a 2 in there, I'm going to plug a 0 in there, I'm going to subtract them. Remember, I'm going to multiply everything by 8 pi, so I'll get 32 pi, and that would be my volume. We just started off with a small one, just a basic function to get you in the mode of how to use the shell method. Okay, let's look at this one. Let's graph this. We should not need a graphing calculator to graph that. Y equals 0 is right here. X equals 0 is right here. And then x equals 1 might be right around there. So the area enclosed would be right here. And we want to revolve that around the y-axis. So that's a shell. Your x limits of integration are from 0 to 1 right there. All right, so again, my question is, are we revolving around the y-axis or a different vertical line? It's the y-axis, so we're going to just put plain old x. And then right here, it's going to be the top function minus the bottom function. So x squared plus 1 minus 0 would just be x squared plus 1. And then we're going to go ahead and distribute. We're going to integrate, so that would give me x to the 4th over 4 plus x squared over 2. 1 and 0, we're going to deal with the 2 pi later. So I plug a 1 in wherever there's an x. Plug a 0 in, we don't really need to. So a quarter and a half is 3/4. Now we're going to multiply that by 2 pi. I like to do that at the end. And there's my volume. All right, let's go ahead and take a look at this. So we said even with the non-calculator ones, we know that a cubic function, we know what the basic shape is, but go ahead and get that graphed on your graphing calculator. So there's our first function. Y equals 1 is right here. X equals 1 is right here. So where would I shade? First of all, we got 3 different functions. It says the region bounded by these graphs. So what am I going to shade? Okay, right here. And we're revolving around the line y equals 2. So yes, because it's vertical, we're going to use shell. Limits of integration. We take a look at these intersect right here at the x value of 0 over to here, x value of 1. But because our line of revolution is not the y-axis, it's going to be that number minus x. And then over here, remember, it's going to be the top minus the bottom. So if I look at my shaded section here, the very top would be my curved one, my cubic one, minus the bottom one is 1. So we're going to go ahead and simplify here. X cubed plus x, those ones would just cancel out. I'm going to go have to FOIL here, so it's going to give me 2x cubed plus 2x minus x to the fourth minus x squared, which I'm going to go ahead and put in order. And I'm going again from 0 to 1, and I'm doing my 2 pi. Notice I have not integrated yet. I've just been simplifying what I have. So let's take the integral. I'm going to kind of run out of room, so I'm going to put it over here. There's no need of me plugging in a 0 anywhere because these are all variables, so we're going to end up subtracting 0 anyway. So just plug a 1 in. So that would give me negative 1/5. Plug a 1 in here. 1/2. Plug a 1 in there. And a 1 in here. Now let's go ahead and get all these as common denominator. So common denominator would be 30. So on this one I'd have to multiply by 6. This one I'd have to multiply by 15. This one I'd have to multiply by 10. And of course this one would be 30. So right now we have negative 16 and 15 is negative 1. Negative 1 and 30 is 29 over 30. And then again, don't forget that multiply by that 2 pi. So I'm going to reduce these. So that then will give me 29 pi over 15. Okay, go ahead and graph this function on your calculator. And that is just going to be the axis, another axis. So let's take a few minutes and get that graphed. I went ahead and zoom mine up a little bit, but it has something like this. Here is y equals 0, and here is x equals 0. Now what we're going to be doing is we're going to be revolving it around the y-axis. So this again is telling me it's a shell because of my revolving axis there. So volume is 2 pi. We're going to leave the limits alone for a second. Again, the question I ask myself is, what kind of line are we revolving around? Is it the y-axis or is it some other vertical line? It is the y-axis, so I put x here. Now what goes in this parenthesis is the shaded area here. And to get that shaded area, I would take this top curve minus this bottom curve. Well, if I'm subtracting 0, that just means I'm going to end up with my y equals there. Now because it's a calculator problem, what I could do is I could write in here y1. Remember we discussed this way back in the day? So now what I need to do is I need to figure out my limits of integration. Well, it's going to be the very left side limit and the very right side here. So right here we can see that it's happening at 0. It was given to us right up here. What I need to do is I need to figure out exactly what point that is for my x. So how do I do that? Well, that's called a 0. So hit the 0 function on your graphing calculator, I believe it's number 2, and it will tell you exactly what number that is. And again, we don't want to round this too early, so we're going to write down that whole thing. So whether you type it in this way, or you want to use the y1 instead of writing out that whole function, it doesn't matter to me. And there's your volume. Alright, so we all should know what y equals x squared is by now. Come talk to me if you don't know what that means or you don't know what that looks like. This one, I know it's got a 0, 0 intercept, but it's going to look something like this. So what I would do is I would personally write y1 is x squared, and then I would write in my calculator y2, and then I would label this as y1, and this one would be y2. This is y2, and this is y1. Here's my shaded area. So to get that volume, I'm going to do 2 pi times the integral from some number to some number, which we'll find out in a minute. And again, it's going to be the top curve minus the bottom curve. And then we're going to have something out in front here. So let's talk about those limits of integration. If this was a non-calculator problem, I would set these equal to each other. Or I can use my calculator and figure out the points of intersection. I'm just going to do one like this, just so you can have it in your notes how we do these by hand. So I will go ahead and subtract x squared. So if I subtract x squared from a negative x squared, I get negative 2x squared. Go ahead and factor out what I can. And we'll see that we have a integration at 0 and then again at 2. You would have gotten the same thing had you hit the intersect button on the calculator. Alright, now what we're revolving around is the line x equals 3. So if this is intersecting at 2 and this is 0, we're looking at this is our line of revolution. So here we're going to put 3 minus x. It's always the number, the other vertical line, minus your x here. Here it's going to be that top curve minus the bottom curve. And the top curve, if you see the height-wise, is the upside down parabola minus the other function. Now again, it's going to be easier if you have been learning to do these all along and go y2 minus y1. That way you don't have to worry about the parentheses in the wrong spot. And then that will give me a final answer of 33.510.